Now let's talk about some of the sums that are based on the nature of the roots. Let's just talk about the question number 1, which says find the nature of the roots. If real roots exist, then find them. So if the real roots will exist, then we have to find them using any particular method. So let us suppose if we have the very first part as 2x square minus 3x plus 5 is equal to 0. So first of all, obviously we'll find the discriminant in order to check whether the real roots exist or not. So let's just check the discriminant first of all. Let us suppose if I'm comparing it with the general equation, we have ax square plus bx plus c is equal to 0. And if I'll compare both of these equations together, we can get the value of a as 2, b as minus 3, c as 5. Let's just substitute it in the discriminant. As we know, the discriminant d is nothing but b square minus of 4ac. So this would be minus 3 whole square minus of 4 into 2 into 5. So we are getting the value of d as 9 minus of 4 into 10, that is 40. And this is nothing but minus of 31. So obviously d is less than 0. And whenever d is less than 0, it means the roots are not real at all. And if the roots are not real, then we do not have to proceed further to find it, because it is mentioned to us in the question that if the real roots exist, then find them, else not. So it means we are done with it, as d is coming out to be less than 0, so roots are not real. It means we do not have to find them. So let's just talk about the second part. In the second part, we have 3x square minus 4 root 3x plus 4 is equal to 0. Now let's just again find the discriminant of this particular quadratic equation first. So we have ax square plus bx plus c is equal to 0 is the standard form of the equation. Let's just compare this with this equation. So obviously a is nothing but 3, b is nothing but minus 4 root 3, and c is nothing but 4. So let's just find the discriminant. So this would be b square minus of 4ac. Substitute all the values over here. So this would be minus 4 root 3 whole square minus 4a is 3 and c is 4. Let's just find the values of it. So this would be 16, 4 into 4 is 16, and then we have 16 into 3. So this would be 16 into 3 because root 3 square is 3, minus of, further we have 4 into 3 is 12. So 12 into 4 is 48. Now let's just talk about this. So d is nothing but is equal to 48 minus of 48, which is equal to 0. So if d is equal to 0, it means that the roots are real and equal. The roots are real and equal. So always remember, whenever d is equal to 0, the roots are real and equal. So if the roots are real and equal, and if they exist, obviously they exist because they are real, then we have to find them. So let's just find it. So as we know that from the case number 2 of the nature of the roots, we have done that if capital D is equal to 0, then the roots are x is equal to minus b by 2a, or again minus b by 2a, because we have the two real and equal roots whenever capital D is equal to 0. So let's just substitute all the values over here. So this would be x is equal to minus b. What is the value of minus b? This is minus 4 root 3 divided by 2a. The value of a is 3, and similarly again we have this value as it is. So this is 4 root 3 divided by 2 into 3 is nothing but 6. Or furthermore, we can write it as nothing but 2 into 2 is 4, 2 into 3 is 6, means we have 2 root 3 by 3 or 2 root 3 by 3, means both of these are nothing but the roots of this particular quadratic equation, and this is nothing but the answer for the second part. As we can see, we have D is equal to 0 for the second case, so it means the nature of the roots is nothing but real and equal to each other. So case number 2 was like whenever capital D is equal to 0, then the roots are always equal and real always. So this is all about the question number 1, which is all related with finding out the nature of the roots, and if the roots were real, then we have to find them.